So I'm brainstorming fungal robotics, fungus and technology, how you can experiment or utilize mycelium and our computers and our technology and robotics. Different experiments and ways that you can even test if this is possible and some potential things you can do with that. It sounds a bit like science fiction, but I think that it is completely possible. We know that mycelium can conduct electricity. We know that it can communicate with other kingdoms of life like trees and insects and bacteria. And we know it can control those to a large extent. Certain fungus can hack into the nervous system or the musculature of insects and control their movements. So they have all of the biological properties you would think is necessary for an organism to control or connect to the hardware of our computers, the motherboard or circuit board or some sort of computer hardware. So one test I would like to do or to see done is whether a mycelium can siphon energy from like a battery. And so if you just have like a normal wire or something, and this is probably would be done with a mycorrhizal mycelium, but the idea is that you have a battery that the mycelium can grow around and in, forming that sort of symbiotic relationship and siphon energy into itself for growing or whatever. See, and I don't know if it would ever be able to really get into the wiring, into like wires, like our copper wires and stuff. So I wonder if you would need to kind of come up with a more biological based wire. Like if you took a mycorrhizal mycelium and you took its symbiotic tree roots and you used its tree roots to create like artificial wires, and then maybe the mycelium will be able to hack into it or tap into it and siphon the energy from your battery. And this has a few applications, but I don't see why that wouldn't be possible if you get it right, because the mycelium are more or less already capable of that. We just need to, there may be a level of learning that the mycelium needs to go through. Like for oyster mushrooms, they can teach it how to break down other materials like cigarettes or plastics and stuff like that. So there may be a level of trial and error within a single mycelium, and maybe not all mycelium can do this, maybe only certain ones. And so there's kind of a lot of room for error and testing that wouldn't necessarily discredit it all. It's all about, what material you're using, what are the circumstances. Like, is there any reason for the mycelium to even tap into this in the first place? So maybe certain tests you need to, so maybe some tests are you have your like aquarium and it's blocked off, or there's a source of water that needs to have a button pressed or like an electrical impulse triggered to distribute like moisture or open up like a doorway that allows it to grow into further parts of it. And so maybe in order to do that, the mycelium has to tap into that electrical switch and then trigger the response, which has some interesting implications as well. If it is able to do that, like on its own with no stimulation from us, that it can control switches or circuit boards or, able to connect and provide the energy or manipulate the energy or electricity required to activate something, some hardware. If that's possible, then the door opens for robotics and computers and software. So ultimately, I think there's three things we could do with it, with mycelium and computers. The first one is that siphoning of energy. Because if you can do that, you could create a artificial tree that solar powered and wind powered, because essentially what a tree is anyways is they're producing a lot of energy through their leaves and through wind blowing their leaves and stuff. So you could create an artificial tree based off of what a normal tree already does, and you have its solar and wind powered. Like, you have little flimsy solar powered leaves that also, when they blow in the wind, they're generating electricity. I imagine it would be much better for the environment, so having giant wind turbines or huge glaring solar panels. Your artificial tree is going to be powering a battery, and that battery is going to have and so this artificial tree and its battery has a root system underground, and this root system is going to connect to mycelium. And so you plant mycelium with the artificial tree. So the mycelium is able to siphon energy from that artificial tree. And then you start planting other trees or saplings around this sort of artificial tree nexus, and make sure there's a clearing around it so it can still get sunlight and wind. But the idea is that you're trying to create you're trying to jumpstart a mycorrhizal forest using energy that the mycelium can have, that it can siphon from your endless source of energy from your artificial tree, and feed it into the trees and other mycelium and mushrooms and accelerate the growth of the forest. We already know that mycorrhizal plants grow exponentially faster, and we also know that mycelium grow faster during lightning and thunderstorms. They like and they use electricity. So I think if you give them a constant source of electricity, you could increase that growth rate and jumpstart forests. And I guess one point of caution in all this would be the potential for electrical fires or just explosions or leaking toxic battery material. So it's not something I think you can really just try out on your own unless you're really good with robotics. I certainly am not. But I feel like there's potential that you could run into some fire issues if you're not careful. But I think in general it would be safe to do. Or at least you could make it safe. So that's one, I think, utilization of fungus and computers, or I guess in this case it's just a battery. But the second would be fungus and robotics. So a cool thing you could do with that, if, again, this is predicated on the fact that they're able to activate switches or do something like that, connect to circuit boards or motherboards. Because if you have a robot and you're able to inoculate it with mycelium, and that mycelium is then able to control it independently, you could do a lot. Other than probably jump-starting the robot revolution, robotics already has a lot of potential in so many different fields. But it would be cool, you could have an enclosure, and you have all different kinds of robots, maybe carts and arms and just kind of small robots, and you have mycelium, and the mycelium is able to control these robots, and you could create a mini factory or station that's just the fungus is moving these resources around. The cart can bring water while the arms do different things, and the mycelium, it would just be creating its own ideal environment, or taking advantage of these robots to kind of enhance or keep its environment going. Maybe some of the robotic processes in this kind of enclosure need to be completed to keep it sustained, keep oxygen, or keep it with moisture, oxygen, or food, or something. You could create little mini environments of robots and mycelium to test out the use and limits of mycelium robotics. Maybe you could have robotic, actual robots, how we think of them in science fiction, or in the future of just a full-on mech suit or robotic. And then the third thing I think is that mycelium connect to the software of computers. Can it connect to our actual web? Can the Wood Wide Web connect with our World Wide Web? Right? Can we have Fungal communication. We know they already communicate with trees, like I said. Can we, in some way, create a machine learning or AI algorithm that is able to interpret and communicate back and forth with mycelium that has entered the software of our computers? And the interesting thing about this, even though it sounds like science fiction, and maybe it is science fiction, maybe that is not possible, but what's cool about this is you're able to come up with ideas with science fiction and potentially drive or lead to explorations to see if that is possible. I think one thing that no one's considered is just how intelligent fungus is. And so you're doing experiments that are just testing other processes of mycelium without considering that this is actually a highly intelligent organism that has done, between its many different species, established communication networks with trees, trading of resources, has figured out how to mind control insects and everything, and break down all sorts of materials and everything from radiation to plastic and metal and other minerals. It's able to do incredible things. So those are just brainstorming the potential for fungal robotics that I think we could see in our lifetime, even if we just dedicate the resources and time to testing it out. If I had a team of like a robotics major, a microbiologist major, or mycologist major, and like an engineer, I think we could do some interesting things. We can test this and see where it goes and how far you can take this. I looked up what kind of has already been done. So this is towards fungal computer. This is a research article I found that they're talking about how fungi can be used as computing devices. The information is represented by spikes of electrical activity. A computation is implemented in a mycelium network and an interface is realized via fruiting bodies. So I think basically they use chemical and electrical activity to stimulate certain growth patterns of its fruit. I believe that's what they're talking about. So they create kind of geometrical patterns. In an automaton model of a fungal computer, we show how to implement computation with fungi and demonstrate that a structure of logical functions computed is determined by mycelium geometry. So this is super interesting. I'll link it, of course. Here is another example of a fungus that can infect a bug, eat it from the inside, kill it, and sprout out and target the next bug. That's just one example of how certain mycelium can get into a organism and pretty much control it from the inside out. Here is a article or website talking about some examples of fungi and insect symbiosis, just to show you the different ways in which they have kind of tapped into a niche of symbiotic relationships with various insects. So that's just interesting to see the array of fungal abilities. I found this guy on YouTube, Carter Hurd. He created a mycelium like robot shell by taking a grow kit and growing it around a molding that he made. So it's kind of a step in that direction of fungal robotics, of creating organic and biodegradable robot components. So there's so many potential for so many different things, whether you just want your computer parts or your house parts to be made of fungus, or you want them to be living components that interact with your artificial intelligence. So it's cool to see someone actually trying that out in at least creating a robot, the exoskeleton of a robot essentially, out of mycelium material. Robots moved by slime mold spheres. So this slime mold was pretty much put into this computer, and they grew slime in a 6-pointed star shape on top of a circuit and connected it remotely via a computer to the hexapod bot. Any light shown on sensors mounted on top of the robot were used to control light shown onto one of the 6 points of the circuit-mounted mold, each corresponding to a leg of the bot. So as the slime tried to get away from the light, its movement was sensed by the circuit and used to control one of the robot's 6 legs. So this is, again, a step in that direction. Slime mold's a bit different than mycelium fungus is, but slime mold is capable of incredible things too. So that's interesting that they're testing that out. And what I say the next step is seeing if it can act independently and control that robot independently. And you probably need to give it a reason to act independently with that robot. If not, it probably won't need to do anything with it. So it's just really cool, all the things you can do. This last article, flexible electronics are a technology that is growing in popularity due to its potential applications in a variety of fields, such as sensors, medical devices, and soft robotics. They're basically using the devices, they're essentially devices constructed with flexible materials embedded with electronic components that are capable of tactile sensing. So there's a few different versions, and these articles are kind of just showing ways to use the material. What I'm interested in, which is incredible in and of itself, what I'm interested in though is seeing if the organism can use our material rather than us using it. And I think that would be super interesting to see and test out and experiment on. And if it pans out, then the potential to revolutionize technology is there, or even just revolutionize a lot of what we think about if we're able to communicate with the fungus through AI and machine learning and connecting it to the internet, or even just having it as robots. I think there's a lot of cool things going forward that we can learn about fungus and that we can use in fungal technologies and fungal robots, mycelium robotics. Yeah, so I was just brainstorming, getting some thoughts out, sharing some of this interesting articles. So thanks for watching and peace out.